What if you traveled at the speed of light? Imagine the thrill of zipping through the cosmos, stars blurring into streaks of light as you hurtle through the vast expanse of space. It's a concept that has fascinated scientists, dreamers, and storytellers for generations. But is it even possible to achieve such incredible speeds? Imagine zipping through space, stars blurring past you. The idea of traveling at the speed of light is not just a flight of fancy, it's a fundamental question that touches on the very nature of our universe. The speed of light is often depicted in science fiction as the ultimate frontier, a boundary that, if crossed, could unlock the secrets of the cosmos. It's a thrilling thought, but is it even possible? The reality, however, is far more complex. The speed of light, approximately 299,792,458 meters per second, is not just a high-speed limit, it's a cosmic speed limit that governs the behavior of everything in the universe. This speed is woven into the very fabric of space and time. Well, there's a cosmic speed limit, the speed of light. This limit is not just a suggestion, it's a fundamental aspect of the universe. Nothing, as far as we know, can travel faster than light. This speed limit is a cornerstone of modern physics and has profound implications for our understanding of the universe. Nothing in the universe, as far as we know, can travel faster. This ultimate speed limit is not just a barrier, it's a defining characteristic of the universe. It shapes the way we understand space, time, and the very nature of reality itself. Light travels at a whopping 299,792,458 meters per second. To put that in perspective, that's about 186,282 miles per second. This incredible speed means that light can travel from the Earth to the Moon in just over a second. That's 7.5 times around the Earth in the blink of an eye. Imagine being able to circle the globe multiple times in less than a second. The sheer speed of light is mind-boggling and highlights just how vast and interconnected our universe truly is. But why is this the ultimate speed limit? The answer lies in the fundamental laws of physics. The speed of light is not just a number, it's a constant that plays a crucial role in the equations that describe the universe. This speed limit is deeply connected to the way space and time interact. It all comes down to physics, specifically Einstein's theory of relativity. According to Einstein, as objects move faster and approach the speed of light, their mass effectively becomes infinite, and it would require an infinite amount of energy to accelerate them further. This makes reaching or exceeding the speed of light impossible for any object with mass. Think of it like this. Imagine a car race where the track itself stretches and changes as the cars go faster. In a similar way, space and time themselves are affected by high speeds. The faster you go, the more space and time warp around you, making it increasingly difficult to reach the speed of light. That's kind of what happens with space and time at super high speeds. The interplay between speed, space, and time is a fascinating aspect of our universe, and it underscores the incredible complexity and beauty of the cosmos. While we may never travel at the speed of light, understanding this ultimate speed limit helps us appreciate the wonders of the universe even more. Albert Einstein, the guy with the crazy hair, revolutionized our understanding of the universe. His theory of relativity tells us that space and time aren't absolute but are relative. They're interconnected like a giant fabric called space-time. Massive objects like planets and stars warp this fabric, creating what we feel as gravity. One of the weirdest things about relativity is that as you approach the speed of light, time itself slows down for you compared to someone standing still. This is called time dilation. It's like something out of a science fiction movie, but it's real. Time dilation sounds crazy, but imagine this. You're on a spaceship traveling at near light speed, moving through the vast expanse of space. The stars blur into streaks of light as you accelerate, pushing the boundaries of human exploration. Meanwhile, your twin stays on Earth, living their everyday life, going to work, meeting friends, and watching the seasons change. Time slows down for you, so when you return to Earth after what felt like a few years, stepping out of your spacecraft, you notice the world has changed. Your twin, who was once your mirror image, is now much older with wrinkles and gray hair, while you remain youthful. They might have gray hair while you're still young. This phenomenon is known as time dilation, a mind-bending consequence of Einstein's theory of relativity. This isn't just a theory. Scientists have actually observed time dilation with atomic clocks. These incredibly precise devices can measure time to an astonishing degree of accuracy. In one famous experiment, they flew one clock in a jet around the world and compared it to a clock on the ground. The jet soared through the skies, crossing continents and oceans. When the jet landed and the clocks were compared, the clock that flew was slightly behind, proving that time really does slow down at high speeds. This small difference, though tiny, was a monumental confirmation of the theory. These experiments have profound implications, not just for our understanding of time, but for the future of space travel and our quest to explore the universe. Imagine the possibilities if we could harness this knowledge to travel to distant stars. As we continue to push the boundaries of science and technology, who knows what other incredible discoveries await us? The future is full of potential, and time, as it turns out, is more flexible than we ever imagined. So, could traveling at the speed of light be our ticket to the future? Not exactly. While time dilation is real, reaching the speed of light is a whole different ballgame. According to Einstein's equations, an object with mass would need an infinite amount of energy to reach the speed of light, which is impossible. It's like trying to push a car to the speed of sound. You just can't do it. There are also other challenges, like the fact that even tiny dust particles would become dangerous projectiles at such speeds. Section 5. Building a Lightspeed cruiser. Let's say we somehow figure out how to overcome the energy barrier. This is no small feat, as the energy required to reach the speed of light is astronomical. Scientists and engineers would need to develop new forms of propulsion, perhaps harnessing the power of antimatter or exotic particles. The challenges are immense, but the potential rewards are even greater. What kind of spaceship would we need to travel at the speed of light? It would have to be a marvel of engineering, incorporating the latest advancements in materials science, energy generation, and propulsion technology. The interior would be designed for long-term habitation, with all the comforts and necessities of home, but in a compact and efficient form. It would have to be unlike anything we've ever built. Traditional spacecraft designs wouldn't suffice. We would need to think outside the box, creating innovative shapes and structures that can withstand the stresses of near light-speed travel. The design would also need to account for the vast distances and the isolation of space travel. It would need incredible shielding to protect it from collisions with interstellar dust and gas. At such high speeds, even tiny particles could cause catastrophic damage. Advanced shielding technologies, perhaps using magnetic fields or energy barriers, would be essential to safeguard the ship and its occupants. This spaceship would also need a way to navigate the vast distances of space. Traditional navigation systems wouldn't be sufficient. We would need advanced star maps, real-time data processing, and perhaps even AI-assisted navigation to ensure we stay on course and avoid any potential hazards. Even at the speed of light, it would take years to reach the nearest stars. The vastness of space is truly mind-boggling. Our journey would require patience, resilience, and a deep understanding of the cosmos. We would need to prepare for the psychological and physical challenges of such a long voyage. We'd need advanced navigation systems and probably some kind of artificial gravity to keep our bones and muscles healthy during the long journey. Prolonged exposure to zero gravity can have detrimental effects on the human body. Artificial gravity, perhaps generated through rotation or other means, would be crucial to maintaining the health and well-being of the crew. Additionally, regular exercise and a carefully planned diet would be essential to counteract the effects of long-term space travel. Section 6. Fueling the impossible. Even with a super-advanced spaceship, the biggest challenge remains fuel. Remember that infinite energy problem? Well, we'd need to find a way to power our Lightspeed cruiser without using all the energy in the universe. Some scientists have theorized about exotic forms of energy like antimatter or zero-point energy. Antimatter is like the opposite of normal matter, and when they meet, they annihilate each other, releasing a tremendous amount of energy. Zero-point energy is the energy that exists even in the vacuum of space. Harnessing these energies could potentially fuel our interstellar journeys. Section 7. Cosmic Crash Course. Traveling at the speed of light isn't just about overcoming physics, it's also about safety. Even a tiny speck of dust could be catastrophic at such speeds. Imagine a grain of sand hitting a windshield at 60 miles per hour. Now multiply that speed by millions. It would be like a bomb going off. We'd need some kind of force field or deflector shield to protect our spaceship from these cosmic bullets. Maybe we could use powerful lasers to vaporize debris before it gets too close. Section 8. The Unreachable Dream. So, is traveling at the speed of light just an impossible dream? For now, it seems that way. The laws of physics, as we understand them, put some serious limits on how fast we can travel. But hey, humans have been wrong before. Who knows what amazing discoveries await us in the future? Maybe someday, we'll find a way to bend the rules of the universe and achieve faster-than-light travel. Until then, we'll keep exploring the cosmos at a slightly slower pace. Section 9. A universe of wonder. Even if we never reach the speed of light, the very thought of it sparks our imagination. It makes us wonder about the vastness of the universe and our place in it. There's so much out there to explore. Billions of galaxies, each with billions of stars and planets. While traveling at the speed of light might remain a dream, it's a dream worth chasing. After all, it's the pursuit of knowledge and the drive to explore that push us forward as a species. Who knows what incredible wonders we'll uncover along the way?